Hello and welcome to today's video. Today I want to show you how we can create our multi-modal local chat app. We want to add voice handling, image handling, PDF chat, everything in one application and all with local models, so you don't have to use OpenAI. We can test the recording, make an audio upload. And with the audio recording we can chat with the model. We can also upload images, ask the model to describe the image. In this case I've given it a picture of the age population in Germany. There we have our output. The model understands, so if you can see in the picture, what we could also do is chat with our PDF files. So I have a PDF file about the Hoover dataset. Tell me what is the Hoover dataset about, and there we got our answer for our PDF chat. This is what you're going to learn in this video. We want to use the OpenAI Whisper model locally to handle the audio data. We want to have multiple chat sessions, and we're going to load quantized models for chatting. We're going to use Chroma database to make a PDF chat available, and we're going to use the LLaVA multimodal model which can understand images. And with that we have a complete chat app which covers everything. The best way to go along with this video of course will be to code along, but I'm going to provide the whole code in GitHub so you can clone it, and along the video there are going to be some places where I will mention some proven possibilities. So even if you just clone the whole repository and don't code along, there's still some points with room for improvement, so you can sit down and make this app even better to your liking. And with that you're going to have the best learning experience. This video was a lot of work. Please leave a like, comment, and I hope you're going to learn a lot in this video. So let's jump right into it. Okay, let's start first by creating our virtual environment. Python-m winf chatwinf, and after that we want to directly activate it. Source chatwinf bin and activate, and then we want to install --upgrade pip, and after that we will install the requirements. So you can click at the link in the description, hop over to GitHub and copy the requirements so you don't have to type it out yourself. You can also just copy the whole repository, but I would recommend to code along obviously so you can learn something. Okay, now we can pip install -r requirements, and you can see we're using Streamlit. Streamlit will be our front end. The advantage is we can have everything within a Python file, and Streamlit in the background handles the JavaScript and creates our web page. I have a video where I go a little bit deeper into Streamlit. Let's jump over to the Streamlit website, shortly look into it. So the main concept we have to keep in mind is that if something changes within an element or within a widget, how it's called here, then the whole script reruns, the whole Python file runs again. And with that all the variables get reset. So they use the concept of session state. Within session state we can store the variables or data which will be needed across multiple runs of the Python file. If you go to any element in the API reference, let's say the input widget for text input, you can see that we have here the function signature defined, which inputs are necessary to define an element or a widget, and here's example code how it will be displayed in the front end at the end. Okay, that's enough with Streamlit for now. You will understand more when we are coding it. So let's hop over. Let's start our file, call it app.py. This will be our main file. Okay, we want to build this up step by step. At first we just want to have the chat interface. After that we will add the audio handling, the PDF handling, the image handling, step by step, and everything done with local models. So import Streamlit as st, define the main function. Let's start simple. st.title and make it multi-modal local chat app. Let's define a chat container. This is simply a div in HTML. This will be a container we can access it later on, because each Streamlit element we define will be, since the script is run from above, will be rendered one by one. We want to define the chat text later, and therefore we want to define the chat container. Let us now define the user input will be st.text input. Type your message here and give it the key user input. We can also define a button, send button equals st button, send key will be the send button, and if send button you would want to create the LM response. LM response builds this response. But right now, let's just keep going before we create the LangChain LLM, and we want to write with chat container st.chat message. We have to define the type here. This will be at first the user, write, and we write user input, and after that chat message with the type AI, write, here is an answer. Okay, let's test it out. If dash name equals main, run the main function, Streamlit, run app.py. Let's put it inside the chat container. So type our message, hello, click send, and there we have it. Okay, here's where we encounter the first problem with Streamlit. If we change something inside this widget and now we click out of it, you can see the Python file got loaded again, but we didn't activate the send button and therefore the chat is not there anymore. So maybe we want to write something here and use the chat interface further, because later we want to upload an image or a PDF file, and we don't want to trigger this message automatically, only when we want to send it. And here, for example, the message stays here after the script has been run again. So obviously we want to delete it now, and now it would be run again when we only deleted it, and the chat would disappear as well. And to mitigate this problem, we want to set an onChange function for the input and also work with session state. So let me show you how we do that. So here at the user input, we want to add the onChange function, and we want to call it setSendInput, and we define it. setSendInput will be st session state, sendInput will be set to true, and here if sendInput or st session state.sendInput, so the chat also gets displayed if we press enter. And what we also want to do here is to clear input field. For this, find clear input field, we want to set st session state user input to nothing, and the user input is already defined in the session state, therefore we can access it like that. But we first have to define the send input session state, because we haven't defined it anywhere. And before we clear the user input, we need to save the input across the session state. So let's call it user question will be the user input, and after that we set the input to nothing. And here of course we get an error that we didn't initialize the session state input. So here we can define it. If send input not in session state, we can define it. Then we need to define the user question, and with that now we need to add another if statement. If st.session_state.user question is not nothing, then we display the chat. And of course we have to set the right here to st session state user question. So now let's hop over to Streamlit again, see what we did here. So for example, hello, and we can see the message got automatically removed from here. With that, we don't have to manually delete it, which would trigger another run of the Python file, and with that everything is now stable. So, but what you can see here, we don't have the LLM yet, and we don't have the chat history. Let's start first by incorporating the LLM and make a real answer. So we want to work with local models, and probably you don't have like 5 GPUs or a GPU which is worth $10,000. So with that we need some quantized models. So we'll hop over to Hugging Face, the blog, and the blog has a lot of models which are quantized. I already explained quantization in another video, which basically puts these large language models in smaller byte formats or bit formats to save some memory. Here the blog has a lot of those quantized models. I got the Mistral 7B Instruct version 0.1 GGUF, and in the model card you can see different quantization methods. So I took the 7B Q5AM model, which is large, it has very low quality loss, and it's recommended. So choose one which suits you, which is applicable with your RAM memory or GPU memory, or maybe you want to choose another model. Here are a lot of models. Just download it, put it into the models folder. Okay, we want to make it right. Here you can see it's already getting a lot of code. Therefore, we want to define a load chain function for LangChain, and here we will just return load normal chain. And this normal chain function we will define in another file. So to keep the overview of everything, because here it's going to get really messy if you would add all the code in one file. Let's create it, LangChains file. Okay, here are the imports which we were going to need, and I will start with loading the config file with openconfig.yaml, yaml.saveload. Okay, define the config.yaml, and within that we will define the model paths where you store the models. So model path, I want to define large model since I downloaded 2 models, which will be here, copy relative path, models, the embeddings. We can directly define the Hugging Face path since we were going to load it from Hugging Face, and you can go to the website, the MTab leaderboard for embeddings. Here you can see them. I just took the BGE large English one. We have sequence length of 500, so 512 tokens. You could choose another one which suits you. Just click on it, copy the link, and then put it in the embeddings path. Okay, now let's hop over to loading it. We're going to need a couple of functions here. I want to define the create LLaChain function, then create memory, or let's call it a chat memory function. We want to create prompt from template function, and we also need the load normal chain function. Obviously, normal chain. Okay, let's start with the LLM. We want to give it the model path and model type. In my case, it's the Mistral. You can also define it here. Model type equals Mistral. It's even better. And the model path will be config model path and large per default, and the model type will then per default be the config model type, just model type. And then we want to load the C transformers. Okay, with C transformers we can simply load the quantized models. Create the embeddings function, which will have the embeddings path will be config embeddings path. Yes, that's it, embeddings path, and want to return Hugging Face instruct embeddings with embeddings path. And I want to use the conversation buffer window memory. So let's create the chat memory now. We want to return the conversation buffer window memory with the memory key of history. We can also add the chat memory, which will just be a chat history, which we will get as input, which will be our history saved in the session state later. And we can also define the K, which will be let's say 3. Okay, now let us first define the prompt template, which will be simply, we will input a template string and return prompt template from template. Okay, so for create LangChain, we want to define in a class. So let's define a class, let's say chat chain definition in itself, and as input we just want to get the chat history. So we want to create self.memory equals create chat memory. The LM will be create LM. Want to also be able to enter the model path, which per default will be the large model, and then here enter the model path and model type. We need the prompt, also we don't need all itself. The chat prompt will be create prompt from template, and the template will be the memory prompt template, and we will define memory prompt template in another file. So prompt templates rich prompt template, I already defined it before. If you go on the Mistral model, sometimes they have defined the prompt template, which is necessary. So here's the S instruction and then the prompt. Therefore, I defined it in exactly this way. You're on the iChatbot, have a conversation with a human, answer his questions simply. You give it the previous conversation as a history and the human input. Okay, and then from prompt templates, import memory prompt template, and there we have it. Exactly. Now we want self.LMChain, and here we'll call the create LLaChain function, and we will input the LM, the chat prompt, and the memory. So here we will define it, the LM, chat prompt, and memory. Return LLaChain, simply like that. Okay, perfect. And the load normal chain will then instantiate chat chain with chat history. We obviously need the chat history here. Okay, let us define the run function. Definition run user input. Okay, so now why do we actually use the LangChain.run function? Because there are different methods how you can call a chain from LangChain, invoke, or just directly call it. So why are we doing it like that? Because with that we can set the stop parameter, which will be in this case human. So we defined the prompt template in this manner with human and colon, then AI and colon. And if we don't define the stop, it might happen that the large language model hallucinates a conversation on itself. So it generates another question and another answer, another question, another answer within one output. Therefore, we define the stop and we put it into a list. The drawback with this method is that we need to give it the chat history instead of that it automatically can work with the chat history. So we define the history, which will be the self.memory chat memory.messages, and that's the chat history. So this will be our LLM output. You can see how many functions we defined here, also a whole class, and if you would have all that in one Python file, everything here in the app file, it would be way too much. Okay, so from LLM chains, import load normal chain, and we also need the chat history. Okay, we want to know from LangChain.memory import Streamlit chat message history. We want to define it here. The chat history will be Streamlit message history with the key of history, and then we can load the LLM chain will be the load chain with chat history. Now we can define the LLM response as the actual LLM response here. The LLM response will be our LLM chain dot run the session state dot user question, and we want to write the LLM response here. So we can just save it, and this is another cool feature from Streamlit while developing. We can just develop, we don't need to rerun everything, and here again takes one positional arguments. Okay, we want to head over to the LLM chains again, and here we need to change a couple of things. We want to define the model equals model path, model type equals model type, and we also want to define a model config file, and this will be in the config file or the model config, and config equals model config. Okay, so let's define the model config here. The model config will be the dictionary with the max new tokens from 512. You can set the temperature. The context length is important, and how if you want to use GPU layers. And we also here obviously need to define model path equals model path, model type equals model type. Actually, we removed that complete since we don't need to pass it. We defined it in the config file. And what I forgot as well, we have to here also define the parameters, prompt, LM and memory. And another thing I forgot after running it, we need to set the user question to an empty string again. We need to only set one equal sign. Let's now finally hop over here, test it out. Hello, who are you? Send it, and now the answer is getting created from the LLM. But now we don't have the chat history. The LLM has the history. Since we have the chat history with the Streamlit message history, we have it in the session state. But yeah, as you can see, what it asked, you asked what I am. So we have the memory now in the session state, but we don't have the history displayed here. Okay, let us now create a chat history. So what we want to do at the end of the code block, we want to check if chat history.messages is not empty, so not an empty list. Then we want to write, let's write chat history. So we want to loop over the messages in chat history.messages, and what we want to do basically streamlit.chatMessage for message type, write message content. And we don't need to write the LLM response here because of the LangChain Streamlit chat message history. Every time the model gets an input, so the LLM chain gets an input and creates an output, it gets directly saved in the session state. So we just load it directly from the session state. Okay, so let's test it out now. Okay, now we will see the chat history is deployed here. And another thing we need to add with chat container, that's why we created the chat container in the first place. So the messages will be displayed above the input field and the send button. There we have it. Now let's create the sidebar and let us add the functionality to save the chat history in a document and load and then switch between different chat sessions. Let us first create the sidebar. Streamlit sidebar title chat sessions. Let's see, there we have our sidebar now. We want to create a directory first with, let's call it chat sessions. Then we want to import our config file as well. So let's copy it over from here. We want to import OS. And now our chat sessions are going to be exactly Plus, we want to also add the new session. The list of our chat sessions is going to be either new session or all the chat sessions in the folder chat sessions, obviously. And in the config file, we want to add the chat history path. Config file, chat history path equals chat sessions. Okay, so next we want to go down here after the session state key definitions and define in the sidebar. So that's how you define elements within the sidebar. We can either do with our st.sidebar or directly st.sidebar, and you want to take the select box. Here select the chat session. The selection will be the chat sessions, and as key we want to give it the session key. Okay, now if we look in the front end again, we see we have here the chat selection. Okay, next thing, we need to save the chat history, and then it's going to be a little bit complicated, the state management, to keep track in which session we are right now. So here's my idea. At the end of the code, we save the chat history, and for that we will define a function which we will put in the utils file, utils.py, import JSON, and we define the function save chat history here. Let us first actually print out the chat history to see the exact format. So print chat history. Now, okay, it's an object, print chat history.messages, and there we can see it's a list with human message, AI message, then again human message, AI message. Okay, and what we can do for each message, let's take the first message, we can convert this message into a dictionary. So let's see the format now. There we have the content and which type it is. We're going to convert it in this format and then save it as JSON and a text file. Okay, so let's actually do it here now. We want to get the chat history and the file path where to save it. That's almost it. We want to create JSON data, which will be a list with message dict, which we just saw, for message in chat history.messages, and JSON data obviously equals. Now we have a list of these dictionary items, and now we can save it as a list. So save the JSON data here. And so you don't get confused, what we just did here, this is called list comprehension. It's basically when you create a list with a for loop within one line. We could also make it in this manner where we define the list and then for message in chat history those messages append the message dictionary within the data. So here we basically put those 3 lines in this one line. Okay, now we also need a function to load the chat history. Okay, that's almost right, but we need to import the human message and AI message from langchain.schema.messages, unpack it, human message ** message. What this does is basically, let's go back again, we have actually, let's run the save chat history first, then we will see save chat history, import it from utils, import save chat history. Okay, we want to actually name it save chat history JSON, also load chat history JSON. After the correct import, we want to define the function save chat history, and in this function, so we first check if streamlit.session_state.history messages is not empty. In the session state we don't have .messages, it's actually directly the list. Then we want to save the history and also here just the chat history, not .messages. Okay, let's for right now what we want to do, let's just write something random here just for testing, and there we have to have it saved. Let's make it more readable. JSON throughout document. In VS Code you open this up with ctlr-p and then you can write those commands. Okay, here you see how the messages are stored. The JSON dictionaries with additional keyword arguments, the content, example, type. And now when we load it, the human message, if you go over to LangChain, you can see the human message and also the AI message has the parameters, additional keyword arguments, content, example, and type. And in this manner, it unpacks the JSON directly so that it actually writes type equals human, content equals hello, and also the other parameters. So it enters all the parameters in this manner. So with those 2 stars, we don't have to type it out. And we also need to add an if statement. If message type equals human, else AI message with those stars for message in JSON data. Okay, and then we return the messages. Now we also have the load chat history function. Okay, perfect. Now we can save the chat history, we can load the chat history. What we need now is the session state management of the session key we are at right now. And for that, I want to add a new function in the utilities file again, which will be definition get timestamp. I want to, okay, perfect, from datetime import datetime, and I want to save it, get the timestamp in the manner year, month, date, hour, minute, second. You can choose another datetime you want. You want to save it accordingly with a timestamp, and we need correct management. So here's my idea. We have set in the select box, we have set the session key. Therefore, if streamlit.session state.session key, if it equals new session, then we want to create a new session key. So streamlit.session state new session key equal will be set to get timestamp, and we also need to import it from utils get timestamp, and we also need to import the load chat history. Now we want to save the chat history with the history path plus st.session state new session key. The idea is, if we haven't saved the session state yet, then we will have the new session. But after we have saved it, we want it to be another session, and then we can click at new session. So the idea here is, if you have new session in a session state, then we haven't yet saved the chat history. So we create a new timestamp. This will be the name for the new chat history, and save it under this timestamp. And else, if it's not saved in this way, we want to just save it under the session key. Because if the session key is not new session, then it's already a timestamp, so another session name, and we can just directly save it under the session name. Because we save after every change in the front end, we save the chat again and again and again. And if the session key doesn't change to new session, then we don't need to create a new session and can save it under the same session. I hope this was not too complicated. It's a little bit all over the place. I hope you could follow my logic. Now we also need to add the new session key to the session state. Remember, all session state parameters have to be first initialized in the first run. So this will be basically none. New session key. Okay, there's an error somewhere. It's in the session state new session key. Okay, now let's test it out again. Now it runs, and then it saves it under a new session. But there's a problem here. Okay, now it is saved, but you can see we still have here selected new session. So every time something changes in the front end, the code will be run again, and we still have new session here, and another new timestamp will be created for the same chat session. So we need to handle this behavior somehow. And for that, the select box has a parameter called index, and in the index we can select in which session we are right now. Okay, something went wrong in the recording, so I have to explain those new session states here for you. In the next step, we're going to define the index, and for that we want to define an index tracker beforehand. And in the first run, the index tracker is new session, so our index is new session obviously. But if the session key equals new session, but the new session key is not none, which happens after the first time the chat history gets saved, since then the new session key will be a timestamp, then we want to first set the index to the new session key, so to the timestamp, and again then set the new session key to none. So if you would create a new session again, then the new session key would be none in that case, and we would stay in the new session until it gets saved again. Okay, and now to the index. Now the index is basically chat sessions.index. So chat sessions is a list with either new session or everything that's listed here in the chat sessions directory. We want to get the index of the element. So either we get the index 0, which is the new session, and we want to also delete those two here, or we get the index 1 or 2. Yes, so new sessions will be the first element in the chat sessions list. Therefore, we get returned 0 if it's new sessions. And yeah, we want to set the index to index. Now, this is a small error, print chat sessions. The problem here is we have the new key only set to the timestamp, but our chat sessions list also contains the .json. So let's just add here the +json to the new session key and remove it from here. We need to also define streamlit.sessionState session key equals new session. Now we have to run it again without errors now. Now we can load the session, and there we see nothing because we didn't load the actual chat history. Okay, so let us now obviously load it here. If the session key streamlit.sessionState.session key is not a new session, then we will write into the streamlit.session_state history, load chat history from history path and the session key. Yes. Okay. Else the history is empty. So here again we load the chat history in the session state, and the Streamlit chat message history takes the chat history also from the history key, and therefore it's also loaded in the LLM. Now finally, let's see, click to a history, and there we get our chat history displayed, and it also stays here because we set the index and track it now. There we see another history, it works. And now when we click the new session, it's empty again. Now test it out and test. Okay, now it will display our chat, and then it will be also saved as a new session. So yeah, we have to first change something again in the front end, and there we can see now it has been reloaded, and this is our new chat history. Okay, perfect. You could also handle this in another way, so there's room for improvement. What you could do, you could change the function in a way that it only saves the chat history if we click on new session, and then you could also give the chat history into an LLM and tell it, give me a title for this chat history, and then you would have it in the manner like in Chatgpt, where your chat sessions are saved with a title, what is going on within the chat session. So this is room for improvement, so you can do this by yourself. So this app here is far from perfect, but if you want to really learn something, there will be a couple of points here where you can refine the things, change it a little bit to your liking, and with that you have a better learning if you do it yourself. And the last thing we want to add here is the unchange. So if we select another chat history, we want to track the index, or let the track index function be called. Definition track index, and this index will basically set the index tracker to the session key, because the session key is the key of the select box, so we directly change the index to the chat we selected, and with that it should now work smoothly. Now we got our base structure, we got our chat history, we got our different chat sessions, saving, loading, the LLM is incorporated. The next thing we want to do, we want to incorporate the voice handling. After that we want to incorporate the image handling and the PDF handling. So let's start with voice handling now. Let's now implement the audio handling part. For that we will use the OpenAI Whisper model locally. So let's head over to the browser again, and at this GitHub repository someone already defined a microphone recorder for Streamlit. We already have it in our requirements. That's how we can use it. We need to import it first, of course, and it actually already has a speech to text implemented. You could directly use that, but we want to use the OpenAI Whisper model now. And what I want to do here, I want the send button and the recording button to be in the same line, and therefore we want to define Streamlit columns. So let's say voice recording column, send button column is streamlit.columns, and then with voice recording column we can now copy over from the repository, let's call it voice recording, and we actually only need start and a stop prompt, and the rest we can remove. Now also add the with send button column, and this send button will be defined in there. Now we can head over to the browser, rerun. There's an error because there are no columns. Now always rerun, and there we have it, the recording and the send button. Okay, now let's directly test it out. So print voice recording. So this is a test, and let's see, there we have it. You can see the recording is in bytes data. What we have to do now, the OpenAI Whisper model, as input it expects an array, so we have to convert this bytes data into an array. Okay, we want to head over to Hugging Face and then OpenAI. At At OpenAI, they have the Whisper release. You can take a model you want to use. You can use the large V2, which can handle most languages, and this is obviously the best one. I don't know why Whisper, the version 3 is not covered here, but they also have it on Hugging Face, so you could also use their best model, version 3. So I'm going to take the small version here right now for the video's sake. That's good enough. And we can scroll down, and there are multiple methods how we can use it. And I want to use the pipeline version here. So let's copy the code, and we want to create an audio handler file. Audio handler.py. Copy that into here. Okay, import touch. We don't need the data set. Okay, let's just find a function called transcribe audio, which gets as input audio bytes. Okay, we don't want to return the timestamps. You can already delete that. We don't need the load data set. Okay, so there we have it. Let's define it a little bit finer. Task equals audio speech recognition, the model. You can change the model up as set, and the chunk length, basically just keep it at that. As far as I know, the model can handle maximum 30 seconds, but it basically just chunks the longer audio down into 30-second parts and then handles that. And we need to convert bytes to array, input audio bytes. For that, we also need to import LibRosa. LibRosa can handle audio files, and import IO. We load the audio bytes with bytes IO, or we wrap it in the bytes IO, and then we load it with LibRosa. We get as output the audio array and the sample rate. Let's print the sample rate. So if there's something not working with the transcription, it might be that the sample rate is off. So you can here then define the sample rate, but it should work in this case. So we converted now the audio array equals convert bytes to array audio bytes, and we just input it here. We have the batch size of 1, then we have the prediction. We return on the prediction, and with that we are already ready here. Now let's go over to the app again, and from audio handler import transcribe audio. What we can do now, and what I just realized, at the send button we also want an on click, and the on click will be there's a function called clear input field, because obviously when someone sends the input via the send button, you need to clear the input field as well. Okay, I just saw that the voice recording actually is a dictionary, and therefore we need to get the bytes. It has the key bytes, so easy. And another thing I just saw, here we can remove the chat container. We had it written here in the beginning when we wrote the chat messages here, but now we have to find the chat history restoring, and the chat container will be used here. So let's check therefore if voice recording, then what we want to do, we want to transcribe audio equals transcribe audio voice recording, and get the bytes. And then after that we want to call the LangChain.run on the transcribed audio, and as easy as that, it should work. Let's also, for safety measures, print the transcribed audio to see if there is some error. Now let us head over and test it out. Hello, this is a test recording. Now let's see, we see it's being handled. Hello, this is a test recording. Perfect, works. And now it will be given to the LLM, and hello, how I can assist you today, and it works perfectly. What is your name? Let's make another test. Yeah, we have it, our chat history with our audio chat. And now what you can also do is ask, continue with chatting in this manner, and it still has the, okay, interesting. Okay, I see it. Every time the script gets rerun, it still has the audio recording in the back, or saved in the session state somehow, and therefore we're going to need the parameter just once. That was the meaning of this parameter, and with that now it should only return it once, and after that not anymore. Okay, let's test it out. Hello, who are you? And now let's just ask something, and we see, okay, now there is no voice recording. Perfect. Now we have the voice recording covered. We can chat via voice. What I like to do, sometimes I have some audio files, so people send me 5-minute long audio messages, and I don't want to hear hear them. So we can just add a file uploader here where we can upload the audio files and automatically just transcribe and summarize it, or at least transcribe it. Okay, so here Streamlit, or let's call it uploaded audio. Streamlit.file uploader with WAV, MP3 and OGG files. Upload an audio file and we can test it here. If uploaded audio, basically what I want to do here, I want to obviously transcribe it. The uploaded audio is not a dictionary, that's a normal Streamlit element where we have to call get value and then we get the bytes. Okay, and after that, what I want to do, I'll call the LangChain run transcribed audio, but before that I also want to summarize this audio file, summarize this text. Let us test it out. I'm going to search for an audio file. Okay, I found an audio file. Let's check it out. And as I see, we have the uploader here. Let's make st sidebar because we want to have it at the sidebar, and there it is. Okay, so now let's just upload it, getting transcribed, and how about printing the transcription, print transcribed audio again. Okay, there it is. There's the output. Summarize this text. This is the audio message, this is the test message. I hope this works, and then we have our summarization. Okay, and I mean you can change this up, you can do here what you want. I just like to have the transcription and the summarization of it, so I don't have to always hear the messages. Okay, another thing with uploaded files, you have to manually remove them, or else if something changes here and it gets reloaded, the file is still in the background and will be used again. So therefore always remove the file if you don't need them anymore. Okay, we finally have our audio handling, can chat with voice messages. Okay, let's start with the image handling, and for that I have something for you. It took me a while to find something. There's the LLaVA model, that's basically Llama, which also understands image embeddings. And there's the repository Llama CPP, which is coded in C++, but we can't directly use it, and therefore we have -Llama CPP. And at first I tried to get it to work, but there were a couple of problems and it took me a while, and I opened here an issue in GitHub. We solved the problem, and now you can easily scroll down here and copy the code. It was not there before. And what you need to do also is to download the model. I am going to download the 7 billion version, and we need the project. The projector is basically a clip model which is fine-tuned on text image pairs. This model is going to be used to create our image embeddings, and then you can download the quantized 4 or quantized 5 model. I download the quantized 5 model. This is our Llama model, which also fine-tuned to handle the image embeddings. So you can download it, put it in the models folder. I create another folder which is called LLaVA, and then I copy it into here. All the links will be down in the description, so you don't have to search for it yourself. So I just copied the model over. Let's create a new file, image handler.py, copy it into here, and we're also going to need import base64, because here's the thing, here's basically a handler. The handler for this model accepts image URLs or base64 encoded images. So we have to also define a function, convert bytes to base64, and obviously image bytes, encoded string will be base64. We need a prefix, data, image, let's make it JPG, base64, and then the string after it. Okay, now our handle image function, we want to get the image bytes and want a user message. Now, yeah, obviously here the clip model path, input the projector path. Yeah, there it is, copy relative path, enter it here. Okay, perfect. And the path to the Llama model, I take the quantized 5 model and put it here. Okay, the context window, so it depends how big the image embedding is. With 1024 that should be sufficient here. Okay, and now we want to create the image base64, convert bytes to base64. And here we just enter the image base64 and our user message. Okay, there's another thing we need to add here in the parameters. Logits all equals true, or else there's going to be an error. And then output equals lm create chat completion. The output will be a dictionary which contains a list with messages, and basically we can return the output like that. And let's also print it once so you can see it. But with this we have the pure text output. Okay, now let's head over to the app again, import the image handler, from image handler, import handle image. Okay, we can easily first copy over the uploaded audio, instead call it uploaded image, upload an image file, and we want it to be JPEG, PNG, and I only want this to be triggered if something is written or a send button is sent. Therefore, we need to encapsulate it here only if the send button or a send input is triggered. If uploaded image, then what we want to do, we again need to call the get value on the image, then we get the bytes value. Also, what I want to add here is with streamlit.spinner. It's basically spinner, which is going to tell us that it's still computing. That's also wrong. I want to define the user message. This will be the default message. Describe this image in detail, please. If we don't write something, so we just click the send button and we just want a description, then we can simply click the send button and have this automatically. And if the state session user question is not empty, then we want some specific message, obviously. Okay, and answer will be that. So now, since this LLaVA image handling model, it does not have the memory which we're using here, which is coupled in the session state. Therefore, we need to manually write these messages in the memory. So we just call chat history at user message, at the user message, and the same with the AI message, not system message, but AI message. The last thing after that, we can set the session state user question to an empty string again. Okay, now let us test it out. Let me get an image of, there I have an image, me doing some sports, some backflips. Now drag in the image file, which sport is performed in this image. Let's ask it, enter. There we see the model gets loaded, it's being processed, and now I'm curious to see what answers. Okay, and there's our answer. The image captures a man performing an impressive trick on a bicycle. He flips it upside down. Okay, it's not completely correct. There are bikes, but they're in the background, but it's pretty good. And with that, we finally have covered the image handling. I hope you could learn something. The next point will be the PDF handling. For that, we're going to need an embedding database, and then we're going to chunk up the documents and chat with them. As you can see here, we don't have the image in the chat history. This is one point which is still open for you to make better here. So you could, for example, when an image is sent, you could save the image bytes for a save chat history function. You could tweak it a little bit to save the image bytes. The same with the voice recordings, and then in the end also display it in the front end, and we have the image displayed. So I just keep it at that, and you can improve the code and have a better learning experience. I bet you're going to have fun doing that. Okay, and with that, let's now start with the PDF chat. Okay, we want to start by creating a function to load the vector database. So let us head over to LangChain again, and here create the function load vec database. You want to input the embeddings. I want to work with the Chroma database. You can use any other database, but I want to use Chroma database in this video, so that's how we're going to use it. We want to use the persistent client from Chromadb. So basically that's how we're going to create it, load it. So do we have Chromadb imported? Yes. We create the persistent client. You can input a path name. I want to call it Chromadb, so we will have a folder here called Chromadb, then the collection PDFs. No, actually we don't need the collection, we don't need to add something, just create it in this manner, return LangChain Chroma. Okay, with that we have the loading of the vector database. Next we need to create functions to add documents to the database. For that I want to create a new Python file, PDF handler. And we need some imports from LangChain, LangChain.text splitter, import recursive character text splitter from LangChain.schema.document, import document, and from LLaVA import load vector DB, and also load embeddings. Finally import PyPDF to As with the audio files or image files or any other files, the PDF files will also be bytes data. So we need to convert the bytes, and that's why we're using PyPDFum 2. If we go over to their website, you can see that they directly support bytes data. So we just need to load it and it's directly converted, and then we can interact with it, get the text from it and everything we need. Here's how we're going to do it. We're going to load it up with PyPDFum 2, extract the whole text, split the text up in document chunks, and then add those to the vector database. And for that, we're going to define a couple of functions now. The first function will be get PDF text bytes as input, and later in our app.py we will define an uploader which can handle multiple files. So you can upload multiple PDF files, and you have to account for that right here. So first we're going to account for that right after we define the next function, which will be extract text from PDF, because we are going to we want a function to handle one file, and this one function will look like the following. So with pypdfum.pdf document from the PDF bytes as PDF file. This is going to be a little bit complicated now. We want to return line break join, and now we want to define a for loop basically. So PDF file dot get page from page number dot get text page dot get text range. So this is basically giving us the complete text of one page for page number in range from length of PDF file. Okay. So you could also simply make every function, call every function here line by line. So for example, like text page would be PDF file get page, no actually page number, and then the text page would be the page dot get text page, and then every function, and that inside a for loop, and then concatenate everything in a string. So but with that we have it in one line. And now what we can do, we can return a list where we call the extract text from PDF on every PDF file that got sent over. Okay, and with those two functions we now have a list, and each element in the list will contain the complete text for one PDF file. Now we need a function to create LangChain documents which are split up in the according token length to accommodate for our embedding context size of 512 tokens, or maybe you're going to use another embedding model, but then you have to account for that right here. Our first function will be get text chunks. This will split up one whole PDF text into multiple files. So we want to define the recursive character text splitter, and now let's go over to LangChain. Okay, we're here at the recursive character text splitter, which is a basic text splitter, and therefore we want to look into text splitter to see that the length measurement function is a basic length len function, and len measures the length based on characters. So we have 512 tokens, and approximately 4 characters are one token. Therefore we can take 2000, let's just take 2000 characters. So we want to define the chunk size as 2000, and let's take the chunk overlap as 50, and let us define the separators as break line or double break line. Yeah, I think that should be it. Okay, define this function get document chunks, and it gets as input the text list which will be created from the get PDF texts, and we want to create a list which will be the documents. So for text and text list we want to make another for loop for chunk in get text chunks. Yeah, we want to call this function on the text, and now input every chunk wrapped inside the LangChain document with page content equals chunk, and then we can return the documents. So now let us define the function add documents to database. We simply get the PDFs bytes as input. Now we want to call those functions, the get PDF text function for the text. After we have the text we want to get the get documents chunks, and now it's basically load the vector database with the embeddings as input, and we can simply call vector database dot add document documents. And with that, you have our documents added. So now let's hop over to the app.py and test it out. For that, we are going to create another file uploader for PDF files. So simply PDF and upload the PDF file. We want to also be able to accept multiple files through. We want to give it the key PDF upload. If uploaded PDF, then what we want to do with st.spinner processing PDF, we simply want to call add documents to database. Perfect. Now from PDF handler import add documents to database. Let's then test it out. Hop over to our Streamlit app again and cannot import name load embedding because we called it create embeddings. Okay, not load embeddings. Another small typo error, accept multiple files. Okay, finally let's input the PDF file and okay, and it seems that this notation is not correct. Therefore, let's just rewrite it. PDF file equals IPDFum, and now another error here in the separator because it's called separators. Okay, I see the error. I'm sorry for this confusion. This here is wrong. We simply need to split the text. Yes, because we input a singular text and not multiple texts, therefore. And Hugging Face and struct embeddings. Another simple error. We need to define model name here in the embeddings. And let's run the Streamlit app again and add the PDF file. It's getting processed. Let's see. The documents are added already. Okay, it works. Finally. I'm sorry for all those errors, but that's what happens when coding. It would be best to test each function to directly verify that it's working, but we found the problems now. It's working now. Okay, let's just make a test.py file. I want to verify that the database worked correctly. So from LangChains import load vector database and create our embeddings. And if name equals main, we want to load the vector base, and I want to output vector database simul search, and I want to search for Hoover dataset. Print the output. Yeah, let's see if that works. So new terminal -3 test.py, and okay, we can see it has worked. Here's our output, the Hoover dataset. Okay, perfect. Okay, now to the final part, the actual chatting with the PDF. And for that, we want to use the retrieval question and answer from LangChain. So we simply load our LM, the retriever, which is our database, and we also want to import our memory, obviously, and then we can chat with our documents. But here's one thing we should think about. This is another LM chain. So in our app, we have to account for that. We can't use our normal chain if you want to chat with the PDFs. So my idea would be to add a toggle and to activate the PDF chat. And if the PDF chat is activated, then the RetrievalQA chain gets loaded instead of the normal chain. And here's how we're going to do that. After defining the sidebar, let's also add st sidebar.toggle PDF chat and the key PDF chat, and the default value will be false. So in my thought would be that if you upload a PDF, you of course or probably want to chat with your PDF file, and therefore we want to set the on change function to toggle PDF chat. And now we need to define the function toggle PDF chat, and for that we simply call streamlit.sessionState.pdfStat is true. If it gets toggled, then we want to call another chain. So if sessionState.pdf chat loads vector database chain, or let's call it PDF chat chain. Okay, and now that's it. We need to define the PDF chat chain function. Let's go over to the LM chains, and I want to call it like this, and define also a class PDF chat chain initialize function. So there are a couple of things we need to do here. We obviously need to create a vector database with with our embeddings, we need to create the memory, we want to create our LLM, we want to get the chat prompt, and then the LLM chain. And also, instead of create LLM chain, we call load tree chain with the LLM, the memory, and the vector database. I'm not sure about the prompt. We might not need the prompt. Obviously, class with 2 S's. And yeah, define the load retrieval chain function. Definition load retrieval chain as input, again the LLM, the memory, and the vector database. And here from LangChain.chains.retrievalQA import RetrievalQA, and therefore we load it. So return the RetrievalQA from LLM, and our LLM will be our LLM, memory our memory, and retriever vector database dot as retriever. Yeah, this should be it. Okay, and if it gets called, we want to return LangChain.run. Instead of human input, we call question. Okay, so I'm not completely 100% sure if it would work right now. Maybe there will be another small error, but let's test it out. So load PDF chain imported from utils. So load PDF chain, and yeah, now let's see. We have that's strange. LangChain.change. Let's see. LangChain.change base. Okay. Chain.base. Now let's see. Always rerun. Load chain. Oh yeah, it's not from utils. It is from our LM chains class. Okay, now finally. So let's toggle our PDF chat and test it out. What is the Hoover dataset about? That's the PDF we uploaded before. It's missing as input. It should have queries, not question, it seems. So then let's just change that in our LM chains file, run query, and there we got the output. So the chain is working. Yeah, with that we have our PDF chat created. You might want to also add a couple of print statements to confirm where we are here. So the PDF chat chain is running. What else do we want? Let's keep it at that. There's another interesting PDF chat chain from LangChain. It's the conversational retrieval chain. So conversation retrieval chain. Okay, what it does, it basically consists of 3 chains, and it takes as input your question, the history, and with your question and the chat history, it creates a new question. So there's a chain, the question generator chain, which looks if your question needs additional information. So to retrieve information from the vector store, because let's say I have now stated the question, what is the Hoover dataset about? And if I would now ask, what can I do with it? Then with the RetrievalQA, we would retrieve from the vector database now data with the question, what can I do with it? And with the conversational retrieval chain, the question generator chain would see, we have talked about the Hoover dataset, so it would generate a new question, what could we do with the Hoover dataset? And then the results pulled from the vector store would be better with this question. And yeah, then it has also a combined documents chain, which gets the output of the vector store and summarizes it. Yeah, and then finally the retrieval chain itself generates then the answer combined with all those chains. The problem with that, well, we have basically 3 chains running here, and on local devices, especially when you're working with CPU, if you're running a good model, it's going to take a while. Even one chain alone is going to take a while, specifically if you're using larger data here. But if you would want to use that, what you could do, for example, in the combined documents chain, you could take a smaller model, which is really good and specifically fine-tuned for summarizing, and then you would reduce the time that would be needed for the summarization. If you want to test it out, go to LangChain, conversational retrieval chain, and test it out. But we are fine now with the RetrievalQA. Again, this is another point here where you could take this existing code and play around with it yourself, and so adding to your learning curve by coding yourself and trying out new stuff. So now let's go to our last part, which will be making those those chat fields looking better with chat icons, adding a little bit CSS to it, and with that we then are finished with our multi-modal local chat app. So let's start with the final step now. Okay, now on to our last part, making the HTML elements here look a little bit better. For that I already have found a repository which has defined some HTML and CSS. Just copy it over, make a new file, HTML templates.py, copy it into it, and then we need to import everything. So from HTML templates, import bot template, user template, and CSS. How are we going to use that? Basically, we can simply just run the write function. So streamlit.write and enter the CSS into it with unsafe allow HTML, and now it renders the HTML inside it. If you wouldn't type unsafe allow HTML, the HTML tags would get escaped and it would not recognize that we want to use HTML or CSS. And then finally here in the chat history messages, what we're going to do. So if message.type equals human, we want to streamlit.write user template replace, and we want to replace this field here. So here are the message fields in the user and the bot template. We want to replace them with our actual message content, and also unsafe allow HTML true, and else bot template dot replace. Yes, exactly. And we can delete that. So let's see. Okay, now these pictures here are from external links. We want to set our own picture instead of this icon, and there's a small problem. Streamlit can't load our picture from our local file system. Therefore, we would have a couple of possibilities to do that. First, we could use our upload field and use the uploaded file, but I don't like this option. I'd say we just take the image which you want, encode it in base 64, and then write it into the image source field. So let us just do that. Let's go to the image file. We already have a function, so add another function, convert image to base 64, image path, and not image path, image file, and we call with open image path as image file and return it in this manner. So now let's just test it out. If name equals main, let us get a base 64 image, and for that I'm going to copy it into this directory, relative path. There we have it. Let's just test it out, terminal, and now run the image handler file. And there's a small problem, bytes like, yes, we need to call .read here, and now it should work. There we have it. So this is our base 64 encoded image. Let's see if we can get it. No. Okay, then let's just write it with image.txt f.write, and then we should have our image here, and in the HTML template we want to open image.txt, image base 64 as file.read, and replace it here. Okay, let's see if that's correct. Error. Okay, let's try it this way. Let us make a function out of it. Definition get user template, and we want to enter the message here. Yes, so we want to return the user template with the message already put into it. Then we don't need to call the replace as well. Let us get back to our app.py file, import get user template, and with that we just call get user template and we input the message content in it. Okay, let's see. Yes, we need to make it an F string. Now it works. Okay, but in the same manner it should have worked without the function. Let me just test it. I'm not 100% sure, but we will see. Yes, okay. Therefore, still make it the same user template, replace it, copy the user template over, and okay, as we made an F string, now we have to replace it in this manner. Okay, now it works. Let us make it the way where it's used with the function. I like it more. I think it's more clean. So get user template, input the message, and then we have it. So I think that's a better way to handle that. Let's do the same with the bot template. So define the function over there for get bot template, and we then going to define the import the function as well over here, get bot template, move the user template, then go over here. We don't need the user template here anymore. anymore, and we just define the function get bot template with the message, make a f string again, remove one of those brackets, save it, small error. Obviously we need to return the bot template, then now we have it. So there's one final thing which you could do. Every time the site gets reloaded, you have to scroll down. What you could do, you could define the chat container under our columns. So define it here, and then we would have our chat input here above. Also, we could call for messages in reverse chat history messages, and now you have the latest message here at the top. So with that, you wouldn't have to scroll down if your chat gets longer, and you directly have the input field here, the message here. Depends on how you like it. So let's for now keep it at that. Okay. And with that, we're finally finished with our little project here. If you made it this far, you're an absolute king. This video took a lot of work. If you liked it, click the like button, leave a comment, and I would encourage you, if there are some things here which you didn't like in the Streamlit frontend, in the way we designed the code, then I will of course provide it on GitHub. You can clone this repository and then code it yourself, change up something, make it better, make it so that you like it. Maybe add the feature that we also displayed the images in the chat history or the audio files. It's all possible, just needs a little tweaking in the way we save or reload the messages and display it in the end. We used different AI models here. Maybe you want to pack everything in one AI model. You could also make the chat, the normal chat with the LLaVA model completely, or the PDF chat. So these are some potential areas for improvements left over for you, so you have the best learning experience. I hope you liked it. Click the like button, click the subscribe button, and see you in the next video.